This missing trimming of the email string might look like a minor inconvenience, but this is a hugely insightful issue. So much so that it forms the third and the final building block of the good validation technique. I call it validation is parsing. The idea is that you cannot separate these two actions, the object creation and its validation, because you cannot do one without the other. And if you try to do so, you will have these issues that I showed you in the previous demo, where we had to duplicate the transformation code, which is this trim method call between the two steps. And it's very easy to forget to duplicate it and allow your domain objects to become invalid, thus violating the first guideline, the always valid domain model. And keep in mind that we have a very simple transformation, just the string trimming. It could have been much more complex. We had this issue with the lack of the string trimming in the first version of our validation code as well. We did not trim our strings before validating them, but even if we did, we would still have to not forget to apply the same transformation when we passed those strings to our domain classes, and therefore duplicate this transformation logic. Alright, but why do I call it parsing, you might ask? That's because parsing is what we essentially do in the createFactory method. Parsing is a combination of several steps that include validation and transformation. When you parse something, you may first validate some basic things, then do a bit of transformation, then validate some more, and so on and so forth. Like I said in our example, the transformation step is very simple, just the trim method call. Other parsers may be more complex. They may also have a hierarchical structure where the parser delegates some work to sub-parsers. Parsers allow you to preserve the information about the transformation process as you do the validation, so that you don't have to apply the same transformations twice. You should think of all your validators as parsers. If we go back to our metaphor with the set theory, we can imagine this third building block as the following. As you might remember, validation is the process of mapping a set onto its subset. This definition is still true, but the mapping process may include additional transformations. For example, here you can see how the bob@gmail.com with several leading spaces gets converted into a string without the leading spaces, and then it finds a match in the set of emails. This third guideline is applicable to not only object creation, but any business operation. All operations may require validation and transformation, and so all of them must implement those as one method that returns a result instance, similar to the create method in the email class. But that's in the ideal case. In practice, there are some edge cases where the strict adherence to this guideline is not necessary, or where we will have to make concessions. For example, it's not necessary to adhere to this guideline if we don't need to do validation. If we have a student class with a structure like this, where there are no validations because we've pushed them to the value objects, then we don't have to introduce a factory method for this class. We can just keep using the constructor. Similarly, if we don't need to do any transformations and just need to validate something, then we can split the operation and its validation in two methods. Here you can see, for example, we extract all the checks out of the enroll method into a method called canEnroll, and then use that method inside the enroll one. This works because we don't need to transform the course and the grade arguments before validating them. If we did, then we would have to keep the enroll and canEnroll methods as one operation. We will talk about concessions we have to make later in this course. Alright, that's it for the theory behind validation and its relation to domain-driven design. With this theoretical knowledge at hand, let's take a look at some practical validation scenarios. Let's move on to more complex validations. Let's look at the student address. Let me delete this one real quick. Good. Currently, we validate the addresses using the addresses validator, which works with collections of addresses. And inside that validator, we also have the singular address validator that works with separate addresses. This validator violates the second and the third guidelines of the good validation technique. It violates the second guideline because these rules don't reside in the domain layer. And it violates the third guideline because we are separating the validation process from the process of object creation. This is an issue because we should trim these strings before allowing them to enter our domain model boundary, but we don't. And there isn't a good way to do so without duplicating the trimming logic between this validator and the controller. And so to fix these issues, we need to introduce another factory method. This new factory method will reside in the address class, similarly to the email and student name value objects. And by the way, this address domain class is going to be an entity and not a value object, because there are multiple addresses inside the student class and we need to differentiate those addresses by an ID field. So I'm inheriting this class from the entity base class. I'm also making its constructor private so that the only way to create its instances is via the create factory method. The create method works pretty much the same as in our existing value objects. The only difference is that it has multiple arguments instead of just one. I'm also trimming those arguments, and I need to transfer these validation rules over to the factory method. If the street length is 0 or more than 100 characters, then we return an error. You can decide how detailed you want the description to be. For example, you may process these two conditions separately, and you can also specify the minimum and the maximum length in the error description while doing so, checking the length of the city, state, and the zip code. Now, in order to use this method in our Fluent validator, we can introduce another extension method. I'm calling this method mustBeEntity, similarly to the mustBeValueObject one. It will work pretty much the same way, except that it will not be restricted to string properties. Now we can replace the use of the validator with this new extension method. Notice that I don't pass the whole address DTO inside the create method. Instead, I'm passing its components. That's because the create factory method resides in the domain layer, and it shouldn't depend on data contracts, which our address DTO is part of. Let's fix compilation errors. Here I'm calling the address.createFactory method instead of the address constructor. In the edit personal info method, I'll comment this code for now. Finally, in our fake repository, I'm also replacing the address instantiation code. Very good, let's run the application. If I remove the street and send the request, you can see the API successfully recognized the error and returned our error message. And if I send a correct request, the API creates a student. Very good. Notice that this address entity consists of primitive types, as opposed to the student entity that consists of value objects only. We could make each of these fields a value object of its own, but the introduction of value objects for each individual property is impractical. It makes sense only in the most complex systems, where you want to get the absolute maximum encapsulation. In the vast majority of enterprise systems, I would draw the following line. If a domain concept only has one invariant, for example, the one related to its maximum length, then I wouldn't introduce a value object for it. If it's something more than that, then yes, a separate value object is justified in this case. Here we only check for the length of each of these fields, nothing more, and so we will keep the primitive types here. Notice that we have another concept that only contains the maximum length validation, and that is the student name. At the same time, we did introduce a value object for it. Let's be consistent with the guideline I just mentioned and remove the student name value object. I'm bringing back the Fluent validations, and I'm also commenting this class. changing the name in the student back to string, and trimming this field manually here. Again, this is an example of concessions I mentioned in the previous clip. Even though all validation rules should belong to the domain layer, it's not practical to create a separate value object for each property with a minimum number of validation rules. Just make sure you are making an informed decision in each particular case. Now, as you might have noticed already, we have reintroduced the issue with the lack of the transformation before making the validation. In other words, we are not trimming our string before validating it. We can fix this by using this transform method. It allows us to indicate which transformation Fluent Validation should do before applying the validation rules. But again, in simple cases, I would just leave the previous version that doesn't do the trimming. Yes, the version with the transformation does more precise validations, but it's more complicated. Also, we are not actually violating the always valid domain model guideline with this simpler validation. We're still not allowing student names to have more than 200 characters. We just reject some edge cases with leading and trailing spaces, and that rejection has obvious workarounds. Let me fix a couple of compilation errors and also the error in the repository. Good.